Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk, we were, again, just chatting, and I said, oh, wait a sec. We got to hit record. You said something. You had some new hearing aid, I think it was, and it has a feature that you can kind of program it or adjust it or tune it with your phone. So you can say, I want more of that bandwidth or more of this frequency or less, right, and stuff like that. And I thought, can you imagine if you're working with the folks making this device, right? Let's say it's an earbud or, listen to music through your phone or a Bluetooth speaker or whatever. And some brilliant person comes in out of marketing and says, well, how about we make it so you can tune it from your phone? And it's like 2 days from launch or something like that. All it needs is this extra thing that we've never heard of before from a vendor we've never worked before. I'm sure it'll work. It'll just fit fine.
Yeah.
Yeah, right.
Yeah. Fortunately, Fred, hearing aids, because of the laws Congress passed not too long ago, are now available over the counter or without a prescription. So, I'm going to try them. They were quite expensive, thousands of dollars per unit. Now they're getting down to hundreds of dollars per unit, and I'm sure the price will drop as the volume and competition increases. But one of the problems in any engineering design is feature creep, and the longer it takes you to develop a new product or whatever, the longer a time your competitor can come up with a new feature that may take the market. And of course, your salespeople come to you and say, "We got to have this in our product."
Well, I remember years and years ago, I was talking to a design team that made networking equipment, kind of for telecommunication,
right,
distribution and stuff. And I was looking at their data sheet of all these features they were announcing for this new product, but I didn't see any evidence of like half of them in the design. And everybody has to do that because we have to confuse our competitors as to what we're really working on. It's like, okay, well, I'll quit looking at that document.
Confuse your customers too.
And confuse your customers too. But every iteration was, they went from 300 baud to 900 baud,
right.
This gear. And then they jumped to 2,400, then it was 5,000, and then it just keeps escalating. So every 6 months, there was just major changes of all kinds of feature sets of these devices. And it was a game of who would find the right mix of deliverables that performed well enough that the competitors had to take 6 months to catch up to you, because it was all about market share.
Sure.
Now, this all relates to reliability, right? Because it's that feature creep at the end of the game. And I've been there where somebody walks in, it's just a drop-in replacement for this, but it has 6 more functions in it. And I'm like, okay, that's probably not true, but do we know anything about whether this will work or not?
Exactly.
And you can do a variety of different things. We can do halt, we can, check vendor records and data and all this other stuff, but it still takes time. And we're about ready to launch this thing, and somebody's got to make a decision. Is it worth doing or not? And part of the challenge from reliability is conveying, yes, we don't know. That doesn't mean it's good, and it doesn't mean it's bad. It's just that we just don't know. Right. And then I usually would get a question like, well, what is it going to take to know? And it's like, well, if we studied this and sent it off to some grad students for about 4 years and did this and did that and everything, and then it's like, all right, never mind, we're going to ship it. And then we find out whether it works or not through customer testing.
Right.
But it was one of those things I think we all face at one point or another, is that we start the program and there's a nice feature set, engineering requirements document. We know how much it's supposed to weigh, what color, and what kind of materials we should use, and all this stuff. And then some things work and some things we can't quite get right. So we adjust the requirements and adjust the feature set.
Right.
And part of, being a good reliability engineer is in my mind, and this is why I brought it up, is that, as features get added, as features change, what we're looking for, what defines what a failure is when one of those things that we really want to work is or is not working. So right from the start. The early requirements is we start looking at designs and we start looking at, how we're trying to achieve it and approaches. And we say, this would be safer from reliability point of view. This one, we'd have to do some work to figure it out. But stay engaged. It's not create a plan and just go run that and provide a bunch of data on a plan on a document that doesn't exist anymore because half of it's changed. Is to stay engaged, stay with the team and stay with the design changes. And ideally you're part of the review process to know what's changing in the requirements documents.
Right.
I don't know. You've seen that, though. I'm sure. He's like, what are you doing talking about that? We can't make that. That doesn't work.
Well, this is the problem. The longer it takes to develop a new product, the more opportunities your competitor has to hear about your possibility, leakage of ideas of what your features you are having and what you're, going to introduce to the market and introduce something better. Okay, so, this is a critical important why developing reliability and lean product development is so important because you need to get the product out and mature as fast as possible to the market. And feature creep and, frozen design is never really frozen. I mean, everybody's, I think, dealing with new product development has had some last minute, sales guy or marketing guy just heard about this feature that was being added to the competitor's product. I mean, when smartphones became water resistant, I'm sure the ones that were developing in the development queue were.
Oh, we got to do this.
Yeah, we got to make it, waterproof, water resistant, and how deep are they expecting it? This phone to be able to go, whatever. And so, adding now a autoclave pressure test to the phone and looking for leakage is a new test that you're going to add. But the market is demanding that. And, your competitors coming out. If you have a folding phone with a bigger screen, which has been
you
tried.
don't hear about those so much anymore.
No.
But it's not like we have a autoclave for leak detection just sitting around in the lab.
No, you don't have a pressure tank and dye penetrant and things like that. You usually have to go out and you
learn how to
use
do it.
Just one. I mean, boy, you're risking it. Depending on the cost of the product, you probably need, 5, 10 or greater.
But it's not always just the last minute ones. Those are the ones that we tell stories about because they really throw a wrench in the whole process. And it's not just the reliability aspect of it. That throws a wrench in the supply chain and manufacturing side of all kinds of stuff when it's late like that. But it's one of the issues that I want to mention and guard against is that I don't know of any program, even when they do it lean and very short, is because part of the development process is that, we want to do this feature. We're not exactly sure how we're going to do it. We got some good ideas, right, for the part of the product that's new, and it might change. That feature might not have the sound power or the fidelity or some other criteria. Right. And if we're still testing that it should be at this particular capability on some measure, but the design intent has changed. The design requirements have changed. Then we're measuring the wrong thing. We're not actually providing good feedback back to the team. So part of it is keeping track of it. And then don't just lock the door. Don't let that sales guy in near the end of the program.
Good luck.
Yeah.
But your company's watching the field, the product and the competitors and knowing, what the market might accept. Also, new devices are being, new components, new chips are being developed that are have more consolidated features in them. And so, it might be things that actually not only are a feature, but a lower cost that are, say, we've got to put this part in because, it's now this much lower. I mean, that happens all during the production life probably of the product too, procurement. But so it's a challenge, and now with just a smartphone or like a PC, just think of all the different kinds of peripherals that could be attached to that PC and that motherboard and whatever. And there's no manufacturer in the world of PCs that can test across all the permutations, all the different devices
Different
that
loads.
PC may be attached to, and how many devices at the same time.
Yeah. Well, you've seen this with they start breaking them up. Especially they have gaming systems and they
Yeah,
have,
right.
basic email type systems, real basic stuff. And then they have them optimized for a business unit or, they try to segment the products to where they expect the uses are. So those gaming systems, they're probably connecting all kinds of consoles up to it and high speed modems and all this other stuff. But you're exactly right. And when I was at HP, the folks that made the business desktop computers, it was this, look, we've got 5 different hard drive vendors. We got 6 different, power supply vendors. We got 4 different motherboard vendors.
Right. And we do some mixed builds. They probably do.
They did
but
mixed builds, but they couldn't do they can't do every version
No.
of it. No. And all of them, it was the weirdest thing is like, well, what's the problem? I mean, they're all meeting the requirements, right? And he says, yeah, except we don't know exactly all the requirements we should be making or specifying because sometimes a particular hard drive just will not behave with a particular vendor's power supply. And we couldn't tell you why,
Right. Yeah. Right. And I remember in, watching a bunch, 30 laptops on a desk, and the programmer or the guys, they were doing the reboot cycles to see if they get a blue screen of death, and identical hardware. And this, I heard the frustration of the BIOS guy, the fundamental operating basic input output of how the system boots up. He says these two are exactly the same piece laptops, and he says, I can't get one to do this, and the other one, and they're exactly the same. He
but
said,
they're not exactly the same. They're not.
That's true. No, because they're assembled. I mean, there's variation assembly.
And there's variation of copper width. There's all these little variations
that's where it's really frustrating. That's an operating margin because it doesn't ever kill the hardware. Usually, it just causes a disruption and a
timing issue or something like that.
Yeah, a signal integrity issue, and that's where I stress that with thermal to limits, and especially thermal, has the ability to change the speeds of chips and boards and dimension, and that's why it's so valuable in extreme limit testing. Is you can with digital systems in almost all cases you can cause it to fail at a certain temperature. I mean, not excluding the built-in thermal interlocks. Once those are defeated, you'll get it to fail at a high level of temperature because of signal integrity issues and the timings, not because of
it just fails altogether. It melts or whatever.
Nothing.
But you have to actually be looking for those things. That's what I found with some people. Yeah, and that's kind of my main point is that as we develop, as we get a new design concept and we get design requirements, we're working with the team to figure out what do they need to know and what do we need to evaluate. And we go figure out how to do this new fangled test for water resistance and all this stuff. And they go, oh, we're skipping water resistance. We're going to make it crush proof now. And like, really?
They're getting pretty good at that, Fred. You ought to see some of the videos of dropping phones from 9 feet.
Well, if they don't survive blenders yet that I know of.
But the complexity of electronics is even just, I remember maybe it was a decade or 15 years ago that Intel made a CPU, and later the board, PC manufacturers were actually the ones that found this floating point error problem.
I remember that. Yeah. And you had to do a particular calculation in a particular order in order to see it in the 15th digit of the calculation. And then so all of us as engineers, we can't use this. We can't trust this. And my boss looked at us and says, you guys add 2-digit numbers in this thing. And only 2 of them, it's 22 plus 88. And you're worried about the floating point error.
Right.
When we're doing finite element analysis and we're doing 100,000 calculations out to 7 decimal points,
those errors start to stack up.
Yeah.
But reality is, electronics is the complexity as it increases, the permutations and variations and the potential. I mean, just testing every single function and cross interaction function it's almost, in some cases might be impossible.
Right. Well, I'm sure it's pretty darn close to it. And you've heard of it in software world where they talk about test coverage. Are we covering all of the various pieces? And there's a limit. There's in hardware even more so. But let's say we get a design document and we have all these features. Even with the original design document, right? The reliability and quality people can't check and test and evaluate and quantify everything. So what I've always found is that you get a first one and then it's basically a discussion about what's the one that we really need to pay attention. What's likely to cause us the most problems, or what's the new vendor? What's the new material? What's the new concept?
Right. And that's kind of a FMEA type approach.
Right. And it's a triage. You figure it out.
You break down the system, you figure out which is, power supplies are always usually very critical. And, those other things. But
well, you can fix those now in software, so it's not an issue. But it doesn't stop. You do it once, you do this prioritization, and then as the design evolves, and as the feature set evolves, and as the solutions to creating those features evolves and changes, our prioritization needs to continue to prioritize this. Because if we swap out something we dismissed as, oh, we got this in the bag, it's the same keyboard we've been using for 10 years, we've never had issues, it's the most rock solid piece we got. And somewhere along the line, they're going to go with butterfly hinges. Remember those?
Right.
We're going to change the mechanism, but keyboards are easy, so it shouldn't be an issue at all. Right. And so nobody really looked at it, except for the way we always looked at it, which was it's not an issue, so we don't invest in it to quantify it, to deal with it, to figure out how it fails. And I don't know what the whole story was with the butterfly keyboard technology, but it pretty much dismally failed in the field. And so, but it's one of those things as it goes, is you have to have that same antenna out or your spidey sensey to say, no, that's a new priority. We need to really focus on that. And then what are you going to drop off the list? Because we only have a finite amount of time and resources and everything else.
Right. You can't do it all. You have to cover the high hitters and the high risk. Anything safety wise certainly is a super priority, but everything else and the features, a lot of them you can fix with software later, and it is done quite often. And those are the easy ones. I mean, you can send an update over the internet. It's pretty easy. But hardware, much more difficult. So making a robust, and once again, defining and establishing the fact that the product operates under very stressful, very high stress limits and has plenty of margin, can be then when a change happens, you have some kind of reference point, you have some kind of baseline to understand if that margin is still there. And any device that really drops that margin is obviously a reliability risk. And you have to make that judgment of whether you can improve that or accept it or mitigate that risk somehow with better cooling or better heat sink or something.
But it's also a business trade-off, right? I mean, if the marketing sales folks say, no, this is critical, otherwise we're just going to be left out of the market.
Right. You're not going to sell many.
Then do we put it in? And then what's the balance of, if too many fail, we also get dinged on customer satisfaction and repeat sales. And it's a lot of the stuff we do, a lot of things we do deal with.
They always say, how many are going to fail?
Yeah, 6. 6 per day? No, 6.
Yeah.
I don't know what the units are. We don't know. It's a guess. It's somewhere between none and all of them.
Get out that crystal ball, Fred. Come on.
Oh, I had one of them. One last story. We'll wrap it up. I did they didn't believe they mounted a circuit board only on one edge, and it was about 6 inches long. And it was a handheld device that one of the features that they wanted is that it would sense clapping.
Oh, great.
Right. And so you know where
through an accelerometer or through sonic?
No, it was through a accelerometer that they would hear, could detect a clap. hitting it. Basically you're clapping your hands holding this thing, and it would detect whether you're on beat or not. It was some party device of some sort. I don't know what it was.
Okay.
And I looked at that and I go, that might be a problem. Circuit boards really do not like bending. And he says, yeah, I thought of that. The mechanical guy thought of that, and he worked with electrical engineering. So he took all the critical components and kept it away from where it was attached, figuring that it would only bend at near the attachment area.
Yeah.
So they really beefed up a bunch of the connections into the socket, but and moved components that they were afraid would crack solder joints and vias and stuff like that, and moved it away. And I thought, okay, that's good. But
this is without any empirical knowledge of testing.
No,
right?
No. And this is all concept. We hadn't even had any protos yet.
From the models.
Yeah. And so I was trying to get them to create me a clear casing that would mimic how it's attached, so I could, shock it and see how it actually moved.
Right.
But even before we got to that, the mechanical guy said, oh, we've got this newfangled finite element thing. Let's put it in there and run it through that and simulate it getting shocked. And it created a sine wave. So there was a deflection at where it was connected and halfway down the board. So the first half would be bending up and the second half would be bending down. And right where that max deflection was a crystal. And this is not good. Right?
Nope.
This is not good. And the mechanical guy says, oh, there's a flaw at the mechanical. That can't happen. This is blah, blah, blah. And he was waving his arms a bunch and smoking cigars or stuff, just making a lot of smoke and mirrors. And I said, all right, so I have to have a sample. So I got one of the early prototypes. I took it to a halt chamber. We added some vibration to it. The crystal broke within a couple of minutes.
Yeah.
And you could see the stress line where that max piece was. And then they believed it. And so we quickly, overnight, they came up with another way to secure that board and dampen out that motion completely.
Sometimes you have to just see it to believe it, Fred.
Yeah. No, it's amazing.
And this is where it's really critical to have the design engineer or whoever was, being doubtful, to show them. I mean, physical pictures, drawings, a cross section of the device, whatever. Yeah. And you did it,
But it was, I had low hopes that he'd even believe it. Oh, you overstressed it. Oh, it was he was going to come up with something, but he's all right, you got it.
But this is a handheld device. You have no idea what the
forces are going to be.
Yeah, how many times it's going to be dropped and
so
cold.
Anyway, it was one of those things that. As they're adding features, and they said, and it was one of those that they said, it was one of the early marketing demos they did for us. He says, oh, and this feature is so you can sense the clapping. And I went, what? That wasn't in the plan.
Surprise.
Yeah. So I think that's the bottom line is you just need to keep your ears open, watch for that feature creep stuff happening or swapping out solutions, the technology or the approach of how we're solving these problems in the design, because a subtle change can make a big difference of how the system performs. And we can't test everything, but keeping that constant prioritization and what's important, what do we need to know, is a big deal for it.
Right. And what's happened in the past, what's come from the field, all that information. And that's where experience really, this job, this world of reliability is, I think, extremely dependent on your experience with actually seeing failures from the field, either servicing or working in an FA lab or somewhere that you've actually seen the physical manifestations of poor quality, low design margin, or misuse by a customer, and understand that is the majority of the causes of failures in electronics, not any intrinsic wear outs modes.
But there's a lot to learn. There's lots we can pull from.
There's a lot more to learn, and the technology will change.
Oh yeah.
But stress will always be relevant, because that's what causes fatigue and aging.
What is I saw a bumper sticker. Gravity does not care.
Yeah.
It's just going to do what it's going to do.
That's right. It's always going to be there. And stress doesn't care. Our electronics are becoming more robust. So it's really for us now to start becoming more robust in our testing and push it harder and push it to these incredible limits. We're not developing a James Webb Space Telescope or a Curiosity rover.
Good grief. Can you imagine the stresses those things are going through?
But those, I don't know exactly in the James Webb, but I know in Curiosity, they're using standard semiconductors, a little bit older than the current, when they had, because they.
Well, you heard just the other day. Well, we probably need to come back and talk about these space vehicles because there's some cool stuff coming out about that.
And they've lasted a heck of a long time compared to what their design, quote, life was.
Oh, yeah. No, that's a whole other episode. We should pay attention to that.
Let's hear it for NASA's reliability.
Yeah, for some other stuff, if they get the calculations right.
Yeah, that's right. They don't convert. I don't use mixed British and
metric and standard but anyway, so the subtle point today, a couple different things we wanted to talk about, but if you've got questions on this, or if you run into challenges on that of keeping up with how things change during the design process, or you've got a good technique to make that work really well, we'd love to hear about it. And if you've got questions on this or any other of the topics we generally rant about or talk about, we'd love to hear from you. Head over to accendoreliability.com/go/SOR. A couple of ways to get in touch with us there. Kirk and I and the other hosts are available through LinkedIn and through the Accendo About pages, plus dozens of other ways, I'm sure. So plenty of ways for you to get in touch. We hope you take a few minutes to drop us a note, a question, an idea or a suggestion. Any of that stuff is all very welcome. So we look forward to hearing from you. So with that, Kirk, now you just got me all spun up. I want to talk about space stuff, but we'll have to hold that thought for another day.
Well, yeah, there's several extreme environments that we could talk about and how they deal with those, but another time, Fred, and it's good to talk to you and look forward to hearing from our audience.
Yeah. Thanks, Kirk. I'll talk to you soon.
Thank you, Fred.
Cheers. Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.